Hi, my name is Vahan Davoudian. I'm a physics experimentalist for 30 years, and today we are going to talk about the electromagnetic wave, which is so important in our life. I have had so many lectures in universities like Regis, Colorado, in Boulder, and then DeVry University. DeVry. And then overall, I have replicated most scientists' experiment as much as I could if I had the, material and everything else. But today, this is going to be so comprehensive because electromagnetic wave was my favorite when I was in college, and I did my best this time. I have so many new, experiment that you're going to love it, and I'm hoping by the end of this video you will learn a lot that it's never been discussed before. First of all, I like to thank so many people. They emailed me, they love these theories. That is great, great, encouragement for me. This is the way you are promoting the science. This is called feedback. In science, if there is no feedback, if you have oscillation, it must have a feedback. If there is no feedback, there won't be oscillation. And the best example is tank circuit, and we're talking about harmonic oscillators, mechanical, like pendulum, and the other one like electronic. But overall, this is going to be so comprehensive, and I want you to pay attention. And at the end of this video, I will show you some experiment, and then I'm hoping that you guys are going to love this. So today is called Electromagnetic Waves by Vahan Davoudian, physics experimentalist, and this is my email, vahandavoudian@aol.com. In fact, electromagnetic waves are so important, in our daily life when we're talking about the telephones and the internet and overall everything, satellites, connecting with the whole world, we have to use the electromagnetic waves. So electromagnetic waves are amazing, and it was discovered by James Clerk Maxwell, one of the greatest scientists. I will explain step by step when we get there. So in fact, electromagnetic waves are oscillating charges, electric and magnetic field, and they just travel in space, and it doesn't have to be any medium. It can travel in vacuum, and that's 300,000 kilometers per second, or 186,000 miles per second. And imagine, in 1 second, electromagnetic wave can travel 7 times around the globe. That's how amazing it is. And in fact, electromagnetic waves are, composed of so many, when we start from the beginning or the end, it's going to be radio waves, and then we have radio waves, microwaves, infrared, visible light, ultraviolet, and X-ray and gamma rays. And in fact, each one I will explain in the next video. The electromagnetic waves are amazing, but I have to give you a little bit history, what happened exactly, and then you guys will realize James Clerk Maxwell was an amazing scientist. When he started this electromagnetism, most things were discovered, but people had no idea that the electricity is not different, magnetism is not different. So there was a hyphen between, it was electricity, magnetism. Electricity hyphen magnetism. James Clerk Maxwell was amazing professor, university professor, and he was a good scientist. He removed that hyphen. Anyway, those electric and magnetic charges travel in space, and one amazing thing happened. When we accelerate the charges and they go up and down or left and right, and then electric field becomes magnetic field become electric field. They just produce one another, and they can travel thousands or millions of miles as long as there's the energy. So let me get the other poster so you can tell exactly how electromagnetic waves work. This is easier to visualize because see, I have the picture of electromagnetic waves, so you can see here. This is the spectrum, and then you can tell. So we start from radio waves, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. And imagine there's a picture over here. It shows that, you know, if you're using your remote, you're using infrared, and then this is the light, and this is the sunshine for the, you know, and then this is X-ray, and then this is microwave, and these are communication. But something amazing happened. I have discussed this before many times. Whenever you have waves like this, it can be, you know, electromagnetic wave, which is transverse. It goes up and down, up and down. But you can tell there is something amazing here. Radio waves are longer, but you know, as it gets here toward the gamma rays, they're getting smaller. So what happened is a proportionality between the waves and the frequency. See, these have long waves, radio waves, but the frequency is less. But as we get toward the X-ray and the gamma ray and the ultraviolet, and then you can see the wavelengths are getting smaller, but at the same time, proportionally, the frequencies are getting. And in fact, today is so important because I have so many experiments. Why? I mean, this is the electromagnetic wave, and of course, you know, this is a good picture, and then you can tell we have like an electric field and we have magnetic field. The green ones are the magnetic field, and the yellow ones are electric field, but you can tell they are exactly at the right angle to each other. See, or 90 degree or perpendicular, and they travel, but see, this is their axis, see, but exactly the way it is, always, you know, electric to magnetic, magnetic to electric. I will explain this in the next posters. And in fact, this poster, I have to explain a little bit, not a lot, but for the, you know, radio waves, electromagnetic, let me put this up. So you can see this is the electromagnetic wave, and then I started from the radio waves from here, from right to left, and you can see it's the longest wavelength. And then in the spectrum, and this case, you know, for the radio and the TV signals and television is using the high frequency, radios are using low frequency, and the next one comes the microwave, and then you can tell it's a personal communication included, you know, mobile phones, Wi-Fi, Bluetooth, and then microwave oven. And the next one is infrared, has a lower frequency and longer wavelength. Well, of course, we can feel this by the heat, because, you know, heat, you cannot see the heat. And the next one, which is so important, is the visible light. And then we have so many experiments for that. It's the only thing our eyes can see, and we have like a low energy on red, and then as it goes toward the blue, the energy increases. And then the next one is going to be ultraviolet or UV, is found naturally in sunlight. Well, of course, we don't see it, but always we get sunburn when we stay now. And the X-ray is extremely important in humans' life because it can penetrate in our body, but of course not the bones, you know, soft tissues. And then that the first time, you know, they discovered they can do so many things with the X-rays. And then they can, cure so many diseases or so many things. And gamma rays are the last one, which is exactly so much energetic. And then they are produced by radioactivity. Well, of course, I don't want to go a lot in astronomy because, you know, most of the time when the, you know, like stars, like, you know, our star is the sun. It'll die in like 5 billion years. Some stars dying already, and they exploded, and then they just radiate gamma rays. But it's a long discussion. Okay, let me get the other poster. Of course, this is so important. Beside James Clerk Maxwell, there was another scientist, fantastic. I mean, he was a great scientist. His name was Heinrich Hertz. And then he discovered the radio waves. And amazingly, it's exactly like, if you remember light will refracted, and the electromagnetic waves are exactly the same. And then you can see here we have the layers of atmosphere, and then you can see there is one all above those stratosphere and everything else. And imagine this is refracted. So what it is, this is helping our communication a lot. And in fact, this part, everything is ionized. I mean, we have free electrons, we have protons. It's like almost like a plasma, and it is so energetic. But it goes to almost 1,000 kilometers above the ground. And you can see here we have like a transmitter. But see the way it is reflected from the here. And then if you are in New York City and I'm in Los Angeles, receiver and transmitter, that is the way this can travel. The reason why, because Earth is a curved, curved, and then by the time you go here, then there must be something above your ground, so it will be reflected. It's exactly like the way I described like 2 weeks ago for the fiber optics. Let me show you that. This is the one you saw like 3 weeks ago, and I'm comparing with Earth. Well, instead of light here, which is doing this optical fiber, ours is a unisphere. See? And then it's over here, so it's exactly like a light. Radio waves are refracted. And in fact, amazing. I mean, the similarities are almost 100%, but like I said, this is in a smaller scale, and then the ours, Earth surface is the larger scale. But exactly, we did the same thing. Radio waves are refracted, and in fact, we get total internal reflection. And this is the way we can communicate, and this is the way we can send signals from New York City to Los Angeles, or even, the way Marconi did. And if you remember, he was a good scientist, Italian scientist. Some friends warned him, Mr. Marconi, you won't be able to transmit over the Atlantic Ocean. But probably, I'm not sure, he was a clever guy. He knew that, yeah, they told him, Mr. Marconi, you will be able to transmit almost 300 kilometers. He said, no. Probably he knew about this, layer that refracting everything. And in fact, he did it, and he got Nobel Prize. Anyway, so this is about that region in the space, which is so important in human's life, and especially when we're talking about communication and things like that. And it's so amazing. See, everything in this region, let me see, electromagnetic wave, ionosphere, is the region, everything is ionized. And it includes thermosphere and mesosphere and exosphere. Everything is ionized, and guess what? It is done by the solar radiation. And you can see here that, layers, and then it shows everything. And like I said, it goes from 48 kilometers to 1,000 kilometers. And in fact, these layers of atmosphere, they are not distinct, but gradually they go up. But overall, this is like a protective layer. And in fact, not only protect us from everything, but also, we can do communication. I mean, how could you communicate from Atlantic Ocean all the way to this part, because Earth is curving? And you can see over here, it shows reflection, refraction, absorption, and the scattering. So electromagnetic waves are so important in our life. You can see this is a radio telescope, and this is Saturn rings, and then this was the good one I could find it. This called Cassini, and this is amazing. And then you don't have to have any astronaut on board. And this was so expensive. What they built it took maybe 20 years. And overall, this probes, or those spacecrafts, they worked like 20 years. But overall, what happens, this was, in Saturn, and then it took many years. And imagine, I had to compare this with electromagnetic waves. If we send the electromagnetic wave to Saturn, it's going to be exactly, let me tell you, it's 1 hour and 18 minutes. But it took this probe, or this spacecraft, to take 6.7 years to get to the Saturn. Isn't that amazing? I mean, 1 hour and 18 minutes versus 6.7 years. And imagine this radio telescope can receive things from, I would say, millions or billions of miles away, because they're radio telescope. You don't have to see them. So they detect everything, and then we can just analyze it. And in fact, I had to print one, which is so important. You can have a look. And this is the largest in the world. It's 70 meters or 230 feet across. And this is in LA, Barstow. And it is so important. This can receive so many things. So imagine all these things are helping us to communicate. And I won't be surprised. Well, in fact, it is possible that one day we can make contact with the aliens, or different civilization, if there is one, or Earth-like things in the future. It is possible. Few minutes ago, I mentioned that that electric field and magnetic field are exactly perpendicular, 90 degrees. But you know what? You won't be able to accelerate, or you won't be able to get electromagnetic wave, but you have to accelerate the charges. When you accelerate the charges, it's a new idea, it's a new thing. I mean, they just propagate in space with the speed of light, exactly speed of light, and there's always electric field is creating magnetic field is creating electric field. And it's amazing that why the charges are accelerated is entirely different. I mean, without the electromagnetic wave, we can't do anything. Even if you remember a few weeks ago, I talked about fiber optics. Fiber optics is part of it, but most of the time when you deal with a satellite, you cannot extend the fiber optic to satellite. You have to use the electromagnetic waves. So I had to analyze and reanalyze and then find out why this electric charge and the magnetic field always are perpendicular. In 30 years, I just did, very careful observation, and then I realized this was amazing scientist, Henrik Lorentz, Dutch physicist. He was one of the greatest. Michael Faraday was the same thing. But you know what? When I compared, I said Henrik Lorentz forces is always, the force has to be perpendicular, 90 degrees. Michael Faraday's laws of induction is exactly the same thing. It must be, if you want to cause induction, it must be exactly 90 degrees. And then alternate, and then Maxwell's electromagnetic wave we explained already, alternating current. And imagine we have like a sine wave, and then one positive and one negative. If you combine them together, one is going to be up and the other one is going to be down. So practically it's on and off, not on and off, positive, negative. And then the next one is the Hans Christian Ørsted experiment with the compass. Let me show you. Of course, I don't want to do this because you have seen this maybe so many times. And imagine, this was in 1820, and then he was an amazing scientist, and then when they discovered there is a compass here and the current flows, so what happened, this exactly is 90 degrees, see? That pointer, this one is red, this one is green, 90 degrees. If you reverse the current, so it's going to be here. It's going to be the other way, so it goes back. So in fact, this was amazing. And then Hans Christian Ørsted this in 1820, and then he discovered that electricity is connected with magnetism and magnetism. Well, of course, Michael Faraday, I will mention later, he went one step further. And then he had no education, but he was genius in experimentalist, and he was a good experimentalist. He put so many, maybe 4 or 5, I think, compasses around the vertical wire. And then he realized that, they move exactly the same. It's all around the wire. So Michael Faraday realized it's 360 degrees. And then he was right. But I have to explain something. When Mr. Ørsted, Hans Christian Ørsted, discovered this, that, electricity and magnetism are related, it took only 1 week, and then Mr. Ampere came up with the, circuit laws, and then Michael Faraday came up with the electric motor, which was, breakthrough in science. Well, of course, it's not like the one we have, but it shows the concept, how the electric motors work, and that was amazing. And they did it, and I'm glad they did it, because this was amazing. And in fact, I had to make my own electromagnetic waves, and then you can see here, they are almost like, perpendicular to each other. Well, of course, this is a slinky, but this is the only way I could, demonstrate that, how they work, see? It doesn't matter if you have the energy here is propagated all the way. This is another one. Well, of course, I'm considered electromagnetic wave like a huge screw. When you go, you turn this like this, this goes up and the other one comes up. So electric field, magnetic field, electric field, magnetic field. So this is the picture for electromagnetic waves, which is amazing. It's exactly like light. They can be refracted, they can be diffracted, they can be reflected, and everything else. So you can see here, this is diffraction, and this can be polarized, and this can be reflected. So it's exactly like the way we discussed for lights. Well, this is my logical analysis for why they are perpendicular to each other. I came up with this idea because my expertise when I was in college, it was alternating current and direct current, and everything has to do with electricity. So I had to came up with this idea, and imagine this is a alternating current, and like I said few minutes ago, I mentioned this is a multimeter, old multimeter, and then you can see it's overlapping this. So this part is positive and this part is negative. See, so if you have like something like this, then you put it on electro. See what happened? But I have to demonstrate this by meter so you can tell. So it's exactly like the same way. So this positive become negative or north becomes south. It's exactly like electromagnetic field because they're changing periodically. So what happened? Positive become negative, negative become positive. But this is one period, but this is half a cycle, and this is complete cycle. I have one more, and then I will explain more. Beside Maxwell, there was another fantastic scientist. His name was Heinrich Hertz. And then I will show you, this experiment was amazing. And imagine, he had high voltage here, he had like induction coil here, and then he had, there's a gap in between here, you can see. And then he applied high voltage. Then he realized there's a spark between. And then he realized that this was the first time, in fact, Maxwell didn't do this experiment, but he just proved it, scientifically by the formulas because he was professor anyway. He did everything, but Heinrich Hertz discovered the radio waves. But unfortunately, at that time, Maxwell was dead because he lived only 48 years and then he died of cancer, poor guy. But Mr. Heinrich Hertz did this, and then he realized there's a spark over here. And you can see he had another one. This is exactly isolated. This 1 meter away, and this is another one. There's also gap over here. So when he had this high voltage here, I realized there's a little bit a spark over here. This was amazing. So the first time electromagnetic waves experiment worked. And then he realized that, they can be transmitted, and that's why, before him, they call it cycle, and then after that it was adopted. Now it's at 60 hertz, and in the United States, in Europe, they call it 50 hertz. It's the number of, frequencies. And in fact, I just analyzed this so many times. I realized that, because the axis of the rotation for the electric and magnetic field is the same thing, it doesn't matter. They always create each other. And in fact, this is amazing concept in physics. They call it cyclotron motion. So anytime you have an electron, in a two magnetic field, S or N, magnetic field, they call it cyclotron motion. So they can rotate like this exactly all the way. So as long as there is an ocean here, free of electron, they can cyclotron. And this was my idea that they will do it. Now I have to demonstrate those things, but before I do that, I have to give you a little bit history. And everything started with a dead frog, and unfortunately, Mr. Luigi Galvani was amazing. He was not a, physicist, but he was doing like a, he was like a actor. So in fact, they realized that dead frog, when they put some like a copper or the other things, the dead frog leg twitched, and they had no idea. So he was so amazed. In fact, he didn't do it. His student did it, and you have no idea what the student name was or so. And Mr. Luigi Galvani came up with the idea. It's called animal electricity. But I don't know why it was a coincidence or what. Alessandro Volta, he was a fantastic physicist, and then he came over, and then he argued with him. They just became enemy, and then I think Mr. Volta was right. It was not animal electricity. There is no animal electricity. And Mr. Volta concluded that the reason why we have electricity is because of two different metals. It's just obvious. Nowadays we call it electronegativity. At that time, Mr. Volta did. The electron was not even discovered. There was no theory for the atom or anything else. If you get like a copper and silver, or copper and iron, or copper or two different metals, stick it in earth or ground, and then you can get a multimeter and then check, it shows 1 volt. Well, of course, that 1 volt is not going to light up any light because of low current. Even if you put it in a pure water, it shows. But the point is, he was absolutely wrong, and now we call it electronegativity. And when Mr. Oersted did this, and then he translated in so many things, he did not formulate it. So it was waiting for Mr. Maxwell to come and, do everything, and then he formalized everything, and then he realized that wherever is the electricity, there is a magnetism. So in fact, this is amazing. He said they are both the same, same force from the different faces, and he was right. Electromagnetism changed our life. And now I have some things that I can tell you. But before I do that, I want to have a good advice for the young generation, because like I said, Luigi Galvani did that amazing discovery. That wasn't his discovery, that was the student, and we don't even know what the student name was. And there was another case in Dutch, lens maker. His name was Hans Lippershey, and he was fantastic lens maker. There was a young boy, and then we have no idea what his name was. He was a young boy, maybe 10 years old, I'm not sure. He got, two lenses by curiosity, and then he could see that the other side of the room, or, workshop. That was amazing discovery. Galileo at that time was vacationing in Venice, and then he heard about this because he was a great scientist, and they call it a spyglass. He had to rush home, and then, discover so many things. And in fact, that was not his invention. Galileo did the most important telescope at the time, because he just did everything by himself. And there was another case that for the young generation, I just want to guys just take advantage of this speech. There was another case. His name was Ernest Marsden. He was 20 years old. He graduated in physics, and one day he went to Hans Geiger, which was helping Ernest Rutherford, and he said, I want to do some experiment. And he was a nice person, Rutherford. They accepted. They had no idea this 20 years will discover the proton, and then he discovered the proton. Well, of course, Ernest Rutherford has amazing scientist. He had to explain everything, and then they gave him recommendation. It's just incredible. 20 years old, Mr. Ernest Marsden, he became a university professor. What I mean, all these things happen because the students are so smart. Always they take, things. And in fact, when Michael Faraday did this electric motor, there was another physicist, very good physicist, and Sir Humphrey, Davy, I think, yeah. They worked together, they were discussing, and Michael Faraday was listening. What will happen is these two forces, electricity and magnetism, will work. And Michael Faraday had no education whatsoever. He could read and write, but he was a great experimentalist, so he made this. Now, I have this, I have to bring it over a little bit closer, you can see. closer a little bit. Oh. Okay, I think now we can see much better. In 1831, Michael Faraday changed everything. And in fact, this is amazing how he did it. You know, you can use this kind of magnet, but this is the way he used. Let me show you. This is a round magnet, and this is removed from the starter of the car. And then you can see he did this. Then he had a coil like this, but I have no idea how big his coil was. And then this was connected to multimeter. At that time, there was no multimeter. They would call it galvanometer, because they discovered, you know, it was not as good as this, but you know, you could see. Let me show you. So Michael Faraday did this, and then he just concluded that, you know, no matter what, anytime you have relative motion between your coil and the magnet, you get current. And then poor man had no idea that, you know, he discovered alternating current. I discovered, you know, I just discussed this in year 2000, Richest University. There were some professors, they loved this idea, but they did not cooperate with me to publish it. And in fact, you know, I discovered this, you know, Michael Faraday discovered the alternating current at that time. Nobody had no idea why, this is going this way, see? You can see, okay? How you see? It's going positive, negative, positive, negative. And in fact, this is exactly like the alternating current. This is exactly like electromagnetic wave. So one side is going positive, one side is going negative. So as long as you have this motion, you will have that, left and right. And then this is the way you can prove that, you know, Michael Faraday was right. And then this was called induction, which is used in our life so many ways. I mean, how God knows how important induction is in our life. So we don't have to wait for Tesla for 60 years. And in fact, he was another genius. He came up with alternating current. But Michael Faraday, what he did, this is called, this when I push this on and off, see, this is alternating current. But nowadays, they don't do back and forth or pull and push. Nowadays, they have, like, they rotate it like this. So it's the same thing. As long as you have this magnetic field is, changing, or it's going, low and high, you can get the electric electric current. And in fact, I have to show you. This is another one which Michael Faraday did amazing with this. This was a history. He made breakthrough in science with this. This is a coil, and you can tell we got two windings, one on the side right and one on the left. So what Michael Faraday did, he just connected this to multimeter, and the other one he connected to, I'm not sure, was it 12 volts or more? I have no idea. So he connected this part to a pile, or they call it pile those days. And, he discovered that, he's not getting induction. And then he had no idea, because the AC was not discovered at that time. He realized when you have this coil, and then one side is going to battery and the other side is going to the multimeter, why is not getting induction? And somehow his genius mind worked. And then what he did, Michael Faraday, he got his finger, then he put on and off, on and off, on and off, on and off, and then he realized he's getting a little bit induction on this coil. But I have no idea how big his coil was, but this is the concept. And 2 years ago, I had to invent my own gear. This is, rotating gear, but you can see I had to carve this one by one. It was not easy, it was very difficult. I said, you know, if Michael Faraday did with hand, I can do it better. So what happened, I'll put, you know, spring over here, see? So every time this spring was going up and down, it was making connection. And if you go on YouTube, you can get this. I think this was 1.5 years ago. And then how could you do induction with, you know, mechanically? This is exactly what. But you know what? That 12 volts I had to change it to 40 volts. That was amazing. But you know, I used lithium ion, and guess what? I could even rotate a, you know, bathroom, you know, induction motor. It wasn't real good, but you know, it was going like 60, 70 RPM, which is not bad. So it shows that, you know, you can do mechanically, but you know what happened? Michael Faraday did, and this is my induction, this is my invention. If you watch it, you're going to love it. And I have never seen this in any place or any books. So I'm hoping that you guys would love this, electromagnetic waves, and then hopefully my next project is going to be satellite. This is going to be also comprehensive. I'm sorry, it's going to be so comprehensive. So anytime you have any idea or you want any suggestion or anything, you can email me, Vahan Davoudian at AOL.com. I'll be happy to help you. And then any college or university they want, I'd be happy to go on my own expenses. I get some experiment, even get there and then explain everything for a student. And I appreciate you guys are watching, and then you emailed me. That is so good for me. That is so encouraging, and that is great honor for me to work with you guys. And I have noticed most of my, you know, people email me, their young generation, and I appreciate that. And like I said, if I do this, like you can see that it's going left and right. Let's see if it's not broken. Yeah. Oh no, it is not broken. See, the needle is going left and right. You can also do this with a multimeter, you know, digital multimeter, but the difference it is going to show minus, plus, minus, plus. So thanks a lot for watching. I appreciate that. And then I think hopefully you learn a lot today, even though, you know, I had to simplify some things. I could not explain everything because it takes such a long time. And one thing I just missed, and if you want to accelerate the charges, that circuit is so important, which was my favorite in college. They call it tank circuit. So it's just a simple circuit. It's a combination of inductor and the capacitor. And by the way, the capacitor was invented by Michael Faraday. That's why they say 10 microfarad, 20 microfarad, 100 microfarad. It was invented by. So what happened? You know, discharge of the, you know, capacitor is charging or, you know, magnetizing the inductor, and the, you know, collapsing the magnetic field is charging the capacitor back and forth and back and forth. So they accelerate the charges, they send it through the antenna, and then what happened is slushing through the antenna. Those charges are going back and forth and becomes electromagnetic waves. And the electromagnetic wave can save our life. And one day, like I said a few minutes ago, it is possible that we can make connection with aliens, we can make connection with different, civilizations. It is possible because electromagnetic waves are real slow compared to the size of even solar system or universe. But now we have no idea what to do. We have to use the electromagnetic wave because 300,000 kilometers per second is beyond our imagination. So good. Thanks a lot. And if you like this video, you can subscribe it, and anytime you have any question, you can ask me or you can email me. I'll be happy to answer because I'm retired. I have plenty time, and next project will be satellite, and then the next one will be maybe nano technology and intelligence, artificial intelligence, so many other things. And thank you very much for watching. Bye bye.